All right, today we're going to solve differential equations. And here it says a differential equation is a mathematical equation that relates some function with its derivatives. For our first example, we're going to find the solution to the given differential equation, y prime is equal to 2x, with the initial condition y of 2 is equal to 1. So that basically means we have this particular solution of 2 comma 1, and we're going to need that in order to solve for the plus c. Now in AP Calculus AB, we only get separable differential equations. So your first step is always going to be to separate this. I'm writing y prime as dy dx, and now I'm going to separate it. I'm going to get all the x's on the same side and all the y's on the same side. So I just multiply both sides by dx, and I'm done with the first step. Now I can do the integral of both sides. On the left side, I have the integral of 1, so that's just going to give me a y. And on the right side, I have the integral of 2x, so that's going to give me x squared. And on one of the sides, I need to put a plus c. Now we're going to use this point right here, which is 2 comma 1. So the x is 2 and the y is 1. We're going to use that point to help us solve for the c. Plug in 1 for the y and 2 for the x. If I subtract 4 from both sides, I get that c is equal to -3. And now I'm basically done. I can plug in my -3 right here. And there we go. There's our final answer. And I've graphed this solution over on the right side. All right, let's look at the next example. We're supposed to find the solution to the given differential equation, y prime is equal to -x over y, with the initial condition, y of 3 is equal to -4. You can see our initial condition is right here. This is the point 3, -4. And if we drew the entire function, it looks like it would be some kind of a circle here with a radius of 5. But because we're doing a particular solution, we must have a function, and it also must be differentiable everywhere. So we got these open circles here. And so the graph over here is just the graph of this particular solution. Now our first step in finding the solution to the differential equation is to change the y prime with dy dx. Remember, these are all going to be separable differential equations. So our first step is to separate the x's and the y's. I'm going to multiply both sides by dx, and I'm going to multiply both sides by y. Now I can do the integral of both sides. On the left side, we get y squared over 2. On the right side, we get -x squared over 2. And we need to put a plus c on one of those sides. I'll put it on the right side. And then we're going to want to solve for y. So the first step is to multiply everything by 2. That will cancel the 1/2 on both sides. The 1/2 is gone. Then I'm going to want to do the square root of both sides. The left side, you get absolute value of y. And absolute value of y is the same thing as plus or minus y. And of course, we can move the plus or minus over to the other side. And now we want to look at our point, because our point is 3 and then -4. When I plug in a 3, I want to get -4. So this is going to have to be a negative here. So I'm going to choose negative out of the plus and minus. And I still need to solve for the c. So to solve for the c value, I'm going to plug this point in, 3, -4. Let's go ahead and solve this. I'm going to multiply both sides by -1. I'm going to square both sides, add 9 to both sides, and I get that c is equal to 25. So we can write our final answer here. Put a box around that. There we go, that's our final answer. And that's just the bottom half of the circle with a radius of 5. Some of you might recognize that equation. All right, let's look at the next example. Okay, here they want us to find the solution to the differential equation. Y prime is equal to x times y squared. They do give us an initial condition, and this is basically the point 2 comma 1. And we're going to need that in order to solve for the plus c. So we'll come back to this later. First thing we want to do is separate all the x's on one side and all the y's on the other side. So I want to multiply both sides by dx, and I'm going to divide both sides by y squared. There we go. And I'm going to want to do the integral of both sides. And on the left side, I'm going to rewrite 1 over y squared. I'll write it as y to the power of -2. All right, let's do these integrals. On the left side, I'm going to add 1 to the power and then divide by that new power. Same thing on the right side. Add 1 to the power and divide by that new power. I do need to put a plus c on one of the sides. I'll do it on the right side. All right, and I can get rid of this -1 if I multiply both sides by -1. I'm going to rewrite y to the power of -1. That's going to be 1 over y. Now I'm putting the right side over 1 because if you ever have a fraction equal to another fraction, you can flip both fractions upside down. And that's going to be really useful because I'm trying to solve for the y. Right now I have 1 over y, but I need y over 1 because I'm trying to solve for y. Okay, y divided by 1 is just y. And now I'm basically done, except I just need to solve for the c over here. Then we can use this point, which is 2 comma 1. So the x is 2 and the y is 1. And I can use that to solve for my c. If I plug it in, I'm going to get 1 equals. Okay, we can reduce this a little bit. I can multiply both sides by negative 2 minus c. I can add 2 to both sides, and then multiply both sides by negative 1. So I'm getting that c is equal to negative 3. So if I plug that in right here, I'm going to get minus negative 3, which is the same thing as plus 3. So there's going to be a plus 3 right here. And I don't really like this 1/2 right here, so I'm going to multiply everything on the top and everything on the bottom by 2. And I also don't really like the plus 6 in the back. I'm just going to move it to the front, so it's going to say 6 minus x squared. I think it'll just look better. There we go. That's our final answer. Let's put a box around it. I always say to check your point just to make sure it works. You never know. You might have a mistake, and you can catch your mistake if you plug that in. If you plug in a 2, you should get 1. And that's just a good way of double checking to make sure that you did everything properly. All right, let's look at our next example. All right, we're trying to find the solution to this differential equation with the initial condition of 0, 10. So again, the first thing we want to do is separate all the x's and all the y's. So you multiply both sides by dx, and we have to divide both sides by y minus 4. There we go. Now we can do the integral of both sides. On the right side, we're going to get x to the third. We'll go ahead and put a plus c on the right side. On the left side, we get ln, and then absolute value of y minus 4. Now we do have to solve for the y, so we got to start by getting rid of that ln. So we're going to do e to the left side is equal to e to the right side. And that will give us absolute value of y minus 4 on the left. The right side, we have e to the x to the third times e to the c. Now on the left side, we can get rid of the absolute value if we put a plus or minus in front of it. And of course, we can move the plus or minus over to the other side. Now I move the e to the x to the third over because this entire piece right now is just a constant, and I'm just going to call it capital A. So I'm going to erase this and put capital A. There we go, and that capital A is just some constant. You can see the left side still has a minus 4, so if I add 4 to both sides, and I'm basically done. I have solved for y. I just need to plug in my point to solve for this a. This a is still a constant that we got to figure out. So our point was 0, 10. So that's x equals 0 and y equals 10. So let's plug that in, and then we can solve for the a. Now when I plug in a 0 for the x, I end up with e to the 0, and e to the 0 is just a 1. So I have a times 1, which is just an a. And then I can easily subtract 4 from both sides, and then I get a is equal to 6. So let's plug in a 6 for our a, and then we're done. There we go. That's our final answer. Let's go ahead and circle that. Again, you always want to check. If you plug in a 0, do you get 10? So you always want to check your initial condition just to make sure that it works. You can see that we do have it graphed over here on the right. This point right here is 0, 10. And I would recommend rewinding this one a little bit and watching this example again. This is a tricky example, but it is a very common one. This whole idea of having e to the power of x to the third plus c, and that's going to turn into e to the x to the third times e to the c. So e to the c is just a constant. And I waited to include the plus or minus before I changed it into just a capital A. So go back and watch this one more time. It is a little bit tricky. All right, let's go ahead and look at our next example. For this one, we're going to multiply both sides by y, and we're going to multiply both sides by dx because we want to get the y's on the left and the x's on the right. There we go. We've separated everything. Now we can do the integral of both sides. On the left side, I'm going to get 1/2 y squared. On the right side, I'm just going to get x squared, and I'll put the plus c on the right side. I can multiply both sides by 2. That'll give me 2x squared plus 2c on the right side. And what I'll usually do is I'll call this C1 so that two C1s can just be traded for a C. That's another common trick that just makes things a little bit easier to work with. Again, we do need to solve for y. Right now we have y squared, so we are going to have to do the square root on both sides. On the left side, we get absolute value of y. And absolute value of y, you can get rid of the absolute values if you just put a plus or minus in front of it. Of course, we can move the plus or minuses over to the other side. And our point does tell you what to choose. When you plug in a positive 1, you're supposed to get negative 2 for the y. So we're going to choose the negative 1. And we're going to use that same point to solve for our c. So when x is 1, y is negative 2. We can solve this by multiplying both sides by negative 1. We can square both sides, and then subtract 2 from both sides. So we get that c is equal to 2. And we can plug it in, and then we're basically done. There we go. There's our final answer. Let's go ahead and circle it. Again, you do want to check your point. When you plug in a 1, do you get negative 2? The answer is yes. You can see it is graphed over here. It's the bottom half of a hyperbola. Of course, we should put arrows over here to show that the graph continues in each direction forever. All right, let's go ahead and look at our next example. All right, our next example is going to contain an absolute value of x. Now remember, for a particular solution, we must get a continuous differentiable function. And you can see absolute value of x is not differentiable when x is 0. So because we're getting absolute value of x as part of our answer, we're going to have to either choose the left side or the right side. So it just depends on where your point is. Your point lands on the left side, then the absolute value of x is going to be traded for negative x. And we're also going to say that x has to be less than 0. If the point lands on the right side over here, the absolute value of x is going to be traded for just an x, but we are going to say that x should be greater than 0. So this is going to be a little bit tricky. That's just going to be our final step. So let's go ahead and do that problem and see what happens. Here we go. It says find the solution to the differential equation with the initial condition negative 1, 1. So we're going to start with the differential equation that they give us. We're going to multiply both sides by dx, and we're going to divide both sides by 1 plus y. Then we're going to do the integral on both sides. There you go. You see the integral right there and right there. The integral of 1 plus y, you might have to do a u substitution, but you would just get ln of absolute value of 1 plus y. And similarly for 1 over x, you won't need a u substitution. That's just going to be ln of absolute value of x. And one of the sides is going to need a plus c. Now, why are we putting plus c only on one side? Well, the reason is that if you had a constant on both sides, you could subtract c1 from both sides. And you might notice that on the right side, we have c2 minus c1, which is just a constant that we can call c. So you really only need just 1 plus c, and it doesn't really matter which side you put it on. So hopefully that explains why we keep putting plus c just on one side of the equation for these examples that we've been working on. All right, let's scroll down. Let's keep solving for y. All right, we're going to have to get rid of the ln here. So we're going to need to do e to both sides. So e to the left side is going to equal e to the right side. And of course, the e to the ln is going to cancel. So you're just going to get absolute value of y plus 1. On the right side, we're going to do e to the ln of absolute value of x times e to the c. On this example, I trade e to the c for an a right away. On the previous example, I got rid of the absolute values and included the plus or minus in the a. It really doesn't matter how you do it. No matter what, you're going to get the same final answer. So e to the power of c is just some constant a. And you can actually use your initial condition to solve for that value of a. If you plug in a negative 1 for the x and a 1 for the y, you're going to get a on the right side and a 2 on the left side. So we actually know that a is equal to 2. So you can always solve for a right away, or you can solve for a later. that also really doesn't matter. All right, let's go ahead and scroll down. All right, we just solved for the a and we got 2. We're going to go ahead and get rid of these absolute values now by putting a plus or minus in the front. It looks like in the same step, I got rid of these absolute values by also putting a plus or minus in the front. So this is an alternate way that you could do it if you wanted to. And we'll get the plus or minuses on the same side. So that's what you see right here, the plus or the minus. And again, we're just solving for y, so we do need to subtract 1 from both sides. Now we do need to choose between the plus or the minus. You can use your initial condition of x equals -1 and y equals +1. If you plug that in, you'll get 1 equals -1 plus or minus -2. So the only way that this will be true is if you go with the minus. If you go with the minus, you're going to have -1 minus -2, which is -1 plus 2. And that does equal 1. So you're going to have to choose the minus in front of the 2x. Now you're basically done here. Here's your answer. But on the previous page, we talked about choosing either the left side or the right side whenever you have this absolute value of x. Sometimes I just leave the absolute value of x all the way until the final answer. And then I look at my point. My point is -1, 1, which is right over here. So I'm choosing the left side. And so that's why I chose the negative x. And if you choose the left side, well, we're going to say, well, x has to be strictly less than 0. So that's why you see this condition right here. So this would be the challenge question. This would probably be the hardest one you get. And it's mostly because of this condition here at the end. I think almost everybody could get to this point. But how would you know to say that x is strictly less than 0? That would be pretty tricky. That would be pretty tough. Just remember that you do have absolute value of x in here. So anytime you have the absolute value of x, you know it's not going to be differentiable when x is equal to 0. So you're going to have to choose either the right side or the left side, depending on where your point lands. And our point landed on the left side, so we had to choose when x was strictly less than 0. So we put this additional condition here, that x was strictly less than 0. Again, this is kind of like a challenge one, so this would probably be the hardest one that you get for separable differential equations. All right, let's look at our last example. Our last example is just an easy example. It says find the equation of the tangent line to the graph of y is equal to f of x at x equals 2 if we know the derivative and we also know a point. Remember, you're doing the equation of a tangent line, but that's still just the equation of a line. So for the equation of a line, you just need a point, which we already have. Our point is 2, 1. And we just need a slope. And we can get our slope from this. We just plug in a 2 for the x and a 1 for the y. That's going to be our slope. So our slope ends up equaling 2. We can go ahead and plug everything in. Y minus y1 is equal to m times x minus x1. You could stop there, or you can distribute the 2. And you can also add the 1 to both sides if you want to. You don't have to, because you might add the 1 wrong with the -4 and end up losing your points on the AP test. So on the AP test, I would probably just stop right here. Remember, you do not have to solve for y.